Here we'll do more polynomial modeling practice. This question says, a drive-in theater owner charges $10 for a ticket and sells 500 tickets a night. The owner finds that when they increase the price to $12 per ticket, they only sell 450 tickets. Keeping the theater open has a fixed cost of $1,000 per night. Part A asks us to find the rate of change in the ticket sales with respect to price. In this word problem, first let's begin by deciding what x and y are. To figure this out, we'll have to look very closely at the wording of the question. We're asked to find the change in the ticket sales with respect to price. The thing we're trying to find will be our y, and the thing that it's meant to be with respect to will be our x. So we'll write down that right now, y will be our sales, and x will be our price. Based on the information we are given, changing the price changes the sales. This means that price will be our independent variable and sales will be dependent. This makes sense because if tickets are more expensive, fewer people are going to buy them. Now, let's use the information we were given to find the rate of change. At first, we're given a price of $10 gives us 500 sales. Now, since price is x, we'll say that our first point is 10, 500, the sales. Our other point is given in the next line of the question. $12 for a ticket changes our number of sales to 450. Therefore, we'll say at a price of 12, that's our x, we have 450 sales, that's our y. Now that we have our x and y points, we can use them to find the average rate of change. The formula that we use for average rate of change goes like this. The rate of change will equal y2 minus y1 over x2 minus x1. So we look to our y values. Our second y is 450 and our first y is 500. So we'll say 450 minus 500, then divide by x2 minus x1. x2 is 12 and x1 is 10. Therefore we'll say 12 minus 10. On top, 450 minus 500 gives us negative 50, and 12 minus 10 gives us 2. If we divide, we'll get negative 25 for our rate of change. This means that for every dollar we raise the price, we'll lose 25 sales. Now that we have the average rate of change, we'll use the point-slope form of the equation to get our model for demand. As a reminder, our point-slope form goes like this. We'll say y is equal to m times x minus x1 plus y1. We will plug in our rate of change for m. We'll plug in our first x value for x1 and plug in our first y value for y1. Therefore, for part B, we'll say y equals our rate of change, negative 25, times x minus x1, and our first x was 10, plus y1, our first y was 500. Then we'll take this negative 25 and multiply it by both of the terms in the parentheses. Now we'll have y equals negative 25 times x is negative 25x, and negative 25 times negative 10 will give us positive 250. And then we'll still have plus 500. Then we can simplify by combining our like terms, 250 and 500. And our demand equation will now be y equals negative 25x plus 750. This will be the equation that models demand. We'll use this demand model for the future parts of this question. Now that we have an equation for demand, we can now find a function that models revenue. To find our revenue, we'll use capital R is equal to price times demand. But if you recall, our price we decided was just our x. Our demand will be the function we just found in part B. Therefore, in place of the demand, we'll say negative 25x plus 750. This entire string will go in place of the demand. We'll place that in the parentheses. Then we'll multiply the x on the outside times both terms on the inside. If we take x times both of those terms, we'll end up with negative 25x squared plus 750x. This will be our revenue function. Now to find profit, we'll use the equation capital P for profit is equal to revenue minus cost. We just found a revenue function in step C. We can place that in place of R. So our profit function will begin with negative 25x squared plus 750x. Then we'll say minus our cost. Now, in the question, in the third line, we have a fixed cost of $1,000 per night. Now, this $1,000 doesn't depend on how many tickets we sell. Our cost will be just exactly $1,000, so we'll place that in this parentheses. This means our profit function will now be negative 25x squared plus 750x minus 1,000. So we've used our demand function to find revenue and use revenue and cost to find profit. Now that we have a profit function, we can move on to our next step and use that profit function to answer some more questions. Part E asks us to find the price that maximizes the profit. Let's remind ourselves that price has to do with x. So we're asking for an x value to maximize the profit. If you see the word maximize, I want you to think about the vertex formula. We will use the vertex formula to find the x. We'll say that x is equal to negative b divided by 2a. Our a value is the number next to x squared, that's negative 25, and our b value is the number next to x, that's 750. We'll now say negative of b, so negative 750, divided by 2 times a, which was negative 25. If we multiply the numbers on the bottom, 2 times negative 25 will give us negative 50. And on the top, we'll have negative 750. If we divide negative 750 over negative 50, we'll get 15. This means that the price that will maximize our profit is $15 per ticket. Now that we know that x, we can find the max profit in part F. To answer part F, we will now let x equal 15 and find the profit. Our equation for profit is negative 25 times x squared plus 750 times x minus 1,000. We now know that our x is 15, so we'll place that inside of the parentheses, remembering to square that 15 that's next to the negative 25, and we can go to a calculator. If you place these numbers into a calculator, you will get $4,625. This means if we charge $15 per ticket, we'll have a profit of $4,625, and this is our max profit.